the first question. Consider an arithmetic sequence. That is an arithmetic sequence. Find the common difference. So to find difference in an arithmetic sequence, just need to go take any two terms, u2 minus u1, for example, the second term minus the first term, and we get 4 out, and then that's it. Or you can just do how much am I adding each time, and it is 4. So the difference is 4. You'd have to write that somewhere for 2 marks. You didn't have to prove that it was arithmetic. It already is. So you didn't have to do it more than once. 10th term of the sequence, well, you can use the nth term formula. Un is equal to u1 plus n minus 1, and that's in your formula booklet. You should find that for the nth term. We know the first term, u1, to be 2. If we're looking for the 10th term, so u10, that means n is 10. 10 minus 1, and that's times the difference, which we just found out above to be 4. Work all that out, and I think you get 38. Part C then, find the sum of the first 10 terms. So that's sum of 10 terms, so that's S10. Now you could do either formula for this. I'm going to use the one that uses the first term and the last term because I do have the 10th term already. I have 38, so I might as well use that one, which is the u1 plus un. But if you use the other one, you would get the same answer. It's just a little bit harder to calculate. So the sum of 10 terms then is 10 terms over 2. The first term we know to be 2. The last term is 38 because it is 10th. So we get 5 times 40, I think that's 200. Okay, and that was all supposed to be done without the calculator, so hopefully you're able to do that, those calculations without the calculator. Question 2. Consider the infinite geometric sequence. So a geometric sequence that keeps going on forever and ever. Find the common ratio. Okay, so to find common ratio, I got to, for a ratio this time, it's geometric, means you're multiplying by something. You need to look at any 2 terms and divide one by its previous friend. So this is 1. The previous one before that was 4480, and simplify this. So because this is a calculator question, I can just put that into the calculator and it'll give me a decimal. Or you could have simplified the fraction, but decimal is fine, or minus 3/4 is fine. I imagine if you didn't simplify it, it'd be okay as well, but you should. B, find 20th term. So this is using our nth term formula. Grab your formula booklet, go to the nth term. u1 times the ratio n minus 1. The 20th term is u20 then. So the first term is still 4480. Just put it in brackets because I know it's going to be multiplied by this ratio as minus 0.75 or minus 3/4. That's the power of 20 take away 1. Now, there's no way I'm doing this without a calculator, and that's why it's a calculator question. Type all that in, and you get around minus 18.9. So interesting enough, in IB, you round to 3 significant figures, always. So that's the first 3 important numbers. So starting with 1, after that just round. So hopefully you know significant figures from your schooling last year or the year before. So that's 3 significant figures. If you didn't round it, that's okay. But yeah, 3 significant figures. All right, part C then. Find the exact sum of the infinite sequence. So this will be, once again, go to your formula booklet and go, right, something's going to give me the sum of an infinite sequence. And because this ratio is between 0 and 1, that means it's going to get smaller and smaller and smaller until it's insignificant. And that is the case here. So the sum to infinity, the formula in a formula booklet is the first term over 1 minus the ratio. Okay, so the sum to infinity, this is available in your formula booklet. Hopefully you found it. 4480 is our first term. 1, take away the ratio. Well, here's our ratio up here. Minus 0.75. Type all that into your calculator, and you get an answer of 2560. So if you want me to re-go over any of those questions, just let me know now. Otherwise, I'm going to move on. So you're self-marking this. Hopefully you're marking this as you go along. Pretty straightforward how any attempt marks will work. If you, for any of these questions, if you use the correct formula but got the answer wrong, you get 1 out of the 2 marks. So if you set up a formula like this for the ratio but got it wrong, you get 1. If you wrote this formula down, started putting numbers into it but got it wrong, you get 1 out of 2. So they're all worth 2 marks, and the same for the question above. Okay. Moving along. Question 3. Okay, what's question 3? So the third term of an arithmetic sequence is 7, and the common difference of the sequence is 3. Find the first term. Okay, there's a number of ways you can do this. You could probably do it in your head, working back 2 terms. You could use the nth term formula. Probably just do it logically. There's 3 terms. The third term is 7. The previous term then is going to be minus 1 common difference, which is 4. The previous term, 1. So the answer to part A is 1. Okay, part B. Find U60, the 60th term of the sequence. So this one, you're going to have to use the formula, the UN formula, the nth term. It's going to be U1 plus N minus 1 times the difference. Now that we've just found U1, we might as well use it. U1 is 1. The first term in the sequence is 1. And we're looking for U60. So it's 60, take away 1. And the difference is 3. Calculator, 178. Part C. The first and fourth terms of this sequence are the first 2 terms of geometric sequence. Okay, so this is where we start to get a little bit perhaps tricky. The first and fourth terms. That means we need the first and fourth term. The first term is 1. The fourth term, well, I need 1 more, so it's 10. Isn't it? 10. Now, I think I can jump straight away to getting the ratio here. It has told me it is geometric. So that means it must have a common ratio. So the ratio for this is going to be U2 divided by U1, which is 10 divided by 1, which is just 10. There's a ratio. Sweet. So if I have the ratio, I need to find the 6th term. I just need to use the general term formula for a geometric again. It's U1, the ratio, and then N minus 1. So if you're looking for the 6th term, U6 is the first term, which is 1, times the ratio, which is 10, times 6 minus 1, because it's the 6th one we're looking for. And it's a calculator question. Probably don't need one, but you can do it. It's 100,000. Okay. All right, so moving along. So this is our first kind of wordy question with you have to think about it a little bit more. Landmarks are placed along a road from London to Edinburgh. The distance between each landmark is 16.1 kilometers. So I'm looking at that, and straight away I think, okay, there's this constant distance between each one. That is my common difference of this sequence, 16.1. I'm going to write that down straight away. If the distance between each one is 16.1, another 16.1, no, that's the difference. The first landmark is placed on the road 124 kilometers from London, the first one. So there's a load of landmarks, landmark 1, landmark 2, landmark 3. So the first one is at 124.7. That means I know where the next one's at by adding this 16.1, don't I? The second one. I'll just do it in my head. 140.8 is the next one, and so on and so on and so on. They didn't ask that, but that's the sequence that's created. Okay, the length of the road is 6671. So at some stage the road finishes 6671, and there's going to be loads of terms, loads of landmarks between those. Okay, determine the distance between the fifth landmark and London. Okay, well, let's find out where the fifth landmark is. So the fifth term in the sequence, U5. So U5, this is part A. So this is kind of my little sketch to just get a handle on the question. And I'm going to actually do some working out here. U5 is going to be the first term plus, well, I'll do out the formula again. So this is what's getting. See how often I return to these formulas. The first term is 124.7 plus the fifth term minus 1 times by the difference, which is 16.1. Calculator job for all this, type it all in, you get 189.1 as your fifth term. Now, is that the distance between the fifth landmark and London? Yes, because London was back here, 124.7 away from the first one. Yeah, so that's it. Determine how many landmarks are along the road for part B. So we know the road length, so that'll be the, at some stage, there's going to be a term around that. It might land here, or it might be right on it. Might be a term number on it. I imagine it's quite like far down. There might be 20 or 30 or 40 landmarks before we hit that spot. So we really want to just talk about that spot. What term number is around there? So if we use that as our answer to this, if we say, okay, term number using our term formula is close-ish to that. So we go, okay, let's see. So yes, the first term, oh, I put the decimal place in the wrong point. That's the first term plus, well, I don't know n. I want to find this. I want to find it around 667.1. And that's times the difference of 16.1 still. Okay. Now I can actually, there's a way of just solving this on a calculator, but we haven't got to that yet. So you could graph it, but perhaps you need to work this out. So let's work it out with as much calculator knowledge as we may have. If you know how to do this on a calculator straight and use equation solver, you can. So I think it's going to be 667.1 minus 12, or 100, when I subtract that from both sides, is equal to 16.1n minus 16.1. Now, this is going to be added to both sides, so on the next line here, I'm just going to go off a page. It's going to be 667.1 minus 124.7 plus this 16.1, and that's going to equal 16.1n. Add these together. Oh, I didn't, sorry, that should be minus, isn't it? Okay, 558.5, and that's equal to 16.1. N, divide both sides by 16.1, so I'm going to do that, 16.1 on the calculator. So n is around 34.6 ish. Oh, it's 34.7 if you want to round it. 6, 8, 9. This is not my final answer, so I don't need to round to 3 significant figures yet. I know I'm off screen, so I need to put that up. Okay, so I get that. Now I need to think about, that is where, so 34.68 is here. That's the 34.68th term. So therefore, is there now 34 landmarks along the line or 35 landmarks? Well, there's the 35th one. What is past where the road ends? Does that make sense? So there must be 34 landmarks. 34, not 35 is the answer. 34. We don't round up, we round back to the 34 is in. The last one is at 34, otherwise you go on past where the road ends. Hopefully that makes sense. So hopefully you're all doing well and following along so far. For attempt marks here, it's kind of similar to the other page. If you've written down a formula and put some terms into it, that some of them are correct, you'll get 1 mark out of the 3 for this one, and out of the 2 for the one above. Okay, let's move along. Question 5. Question 5. Let's look at this. The first 3 terms of geometric sequence are those. Okay, find the common ratio. That's very straightforward. Find the common ratio, 2.4 divided by 0.8. 3. Fits in 3 times, I think. Part B, find the value of the sum of the first 8 terms. That's what S8 means. Sum of the first 8 terms. So if this continued on for 8 more terms, add those all together, which of course you could do by just keeping this pattern going and then add up all the answers, but it's probably easier to use the formula. The sum of n terms, I'm going to use it this way around. I don't know the 8th term, so I'm not going to use the formula I used in the previous question. I'm going to use the or to the n minus 1 all over or minus 1 formula. I'm going to use that one this time. I could find the 8th term and then use it, but I might as well just go straight to that. Okay, so the sum of 8 terms then is going to be the first term, which is 0.8. The ratio I just found was 3. There's 8 terms, so it's going to be 3 to the power of 8 minus 1 all over 3 minus 1. Now, if you used it the other way around, 1 minus, you're going to get negative here, but they'll just cancel each other out and you'll get the same number. And if you type all that into the calculator, which I'm not going to do because I already have the answer, it's 2624, I think. Question 5. C then is very similar to the previous question. What term in the sequence is the least one? So Sn, so the sum of terms, is greater than 35,000. Okay. So at some stage, we're going to add up the terms. So adding up the first 8 terms gets here, 2,624. So maybe if we add up the first, this is an example, add up the first 10 terms, you might be around 5,000. Add up the first 15 terms, you might be around 40,000. So that, so it's not the 15, so maybe it's the 14 to 13, something like that. So what you're looking for is that point where the sum of terms goes over 35. Okay, so in order to do that, we look at 35,000. We look at it. So part C, make it equal 35,000 equals the sum of terms. So we use the sum of terms formula, and then we're trying to find what n is of this. The first term is going to be 0.8, isn't it? The ratio is still 3 to the power of n, and 3 minus 1, 35,000. Okay. If you rearrange this and multiply a bit, perhaps you can divide down and, well, let's just do it, so make sure we're all on the same page. That's 3 minus 1, which is 2. Multiply both sides by 2, you get 70,000 is equal to 0.83n minus 1. And divide both sides by 0.8. Maybe I'll start to use the calculator now. 70,000 divided by 0.8. Okay, so that 87500 is equal to 3n to the power of n minus 1. So I got rid of that multiplication. Add 1 to this side. So I get 87501 is equal to 3 to the n. Okay, Now, once again, how do I solve this? You can solve this using if you remember logs and exponents from last year, you can solve it pretty easily. Let's say you don't remember how to use logs and exponents. You could also graph this. Graph the graph of 3 to the x and see where it gets past this number. Graph this one as well. So you do two graphs. You do y is equal to 3 to the x and y is equal to 8750. Just set your scale and see where they cross over. That will give you your answer. And if all else fails, 3 to the power of something gives this. So 3 to the power of 15, too much. 3 to the power of 10, too little. But it's pretty close. See, 3 to the power of 10. So 3 to the power of 11, 177,000. Okay, so it's gone from 59,000 to 177,000. So that means that one, and then it switches to greater than. So we want the smallest number. So does that mean 3 to the 10 is going to give it? No, it's going to be too little because it has to be exceeding. So it's 3 to the 11. It's the first one that exceeds in this one. Or greater than. So the answer is when n is 11. That's the answer. So maybe some of you put when n is 10, but n is 11. So I solved it using trial and error. Okay, let's move on to question 6. The third term, so this you should have done without using a calculator, but perhaps maybe some of you did, but you shouldn't need one. The maths is not that difficult. The third term of an arithmetic sequence is equal to 7. So anytime I see something like this, I go bang, okay, let's have a little look. That third term in the sequence is 7. Cool. And the sum of the first 8 terms is 20. Okay, so S8 is 20. And I have a formula for this. I have a formula for that. Sweet, so I'll go to it at some stage, I'm sure. Find the common difference and the first term. Okay, well, I have loads of information. So let's use this formula. Some of the first 8 terms. Some terms formula. I'll use the one that has, we know the 8th term. U1 plus UN. That's what I'm going to use. I'm going to use this. So when sum of the 8 terms, it's going to be 8 over 2. The first term, which we still don't know, plus the 8th term. And that's the first. I haven't put them in yet. So I'm going to go back now. I'm going to use this sequence, which I kind of blocked off here, so I'm going to rewrite it. First term, second term, third, fourth, 5th, 6th, 7th, 8th. Okay, so that's 8 terms. And we know this is an arithmetic sequence, so I know that there's a difference. So this next term would be 7 plus a difference. And this one is going to be 7 plus 2 differences. 7 plus 3 differences. 7 plus 4 differences. 7 plus 5 differences. Here is the 8th. So that term I can replace with 7 plus 5d's. Going backwards, 7 minus the difference is going to give the one before 7. And 7 minus 2 differences is going to give us the one 2 before 7, which is the first term. So now I'm going to fill out this form. I'm going to rewrite this. The sum of 8 terms is 20. So I'm going to say that's 20. That bit's 20. 8 over 2 is 4. The first term, I'm going to use 7 minus 2 differences. Plus, the 8th term is going to use 7 plus 5 differences. And when I notice this, it's only an equation with one unknown. It's the only thing I don't know is the difference. So 20 is equal to 4 times, 7 plus 7 is 14, and minus 2 differences plus 5 differences is 3 differences, or 3D. Divide both sides by 4 to get rid of this 4 times, or I can multiply in and then divide later, but 4 times, divide both sides by 4, I get 5 is equal to 14 plus 3 differences. Subtract 14 from both sides. I think I get minus 9 is equal to 3 differences. And therefore the difference must be negative 3. Minus 9 is equal to 3. Now I ran out of space, so it's a bit, I shouldn't have written so big at the start. And therefore I know what the first term is going to be. If the common difference is negative 3, I know that the first term is 7 minus 2 differences, minus 3. So 7 minus 2 times minus 3. Well, minus 2 times minus 3 is plus 6. So it's actually 13. And that makes sense if it's going down. So it's 13, then 10. Okay, so the difference is going down by 3. And that makes sense. To me, anyway. So there's my 2 answers. First term is 13, and the common difference is negative 3. Okay, now we are on to our binomial theorem questions. The final 2 questions in the exam. Expand this in descending powers of x, and then just simplify your answer. So this should be a straightforward binomial theorem question. You can use a calculator if you wish. I am not going to use a calculator for this. I'm just going to start by, well, I know that there's going to be, the first term in this sequence is going to be 2x to the power of 4. I know the second term in the sequence is going to have in it a 2x to the power of 3. Because remember, binomial, you take this first term, it decreases in power. I can continue with that if I want. I can just, I know it's going to be 2x, not 23, 2x to the power of 2. And eventually it's going to be 2x to the power of 1. And then the last one's going to be 2x to the power of 0, so I'm not going to put that in. All right. Now, if I want, and it's a non-calculator question, I'd have to do this. I'd have to use Pascal's triangle, wouldn't I? To find. Now, I don't have to. I can use the calculator and use the choosing one, but I just want to show you without the calculator. So if it's to the power of 4, I use the one with 4 here. So I know the first one's going to be 1. The second term is going to have a coefficient of 4. Third term is going to have a coefficient of 6. The next one's a coefficient of 4. And the last one's going to have a coefficient, well, I'll write in 1, but it's probably unnecessary. Okay. Now we look at the minus 3. The first term is not going to have a minus 3 in it because it's going to be to the power of 0. Second term is going to be minus 3 to the power of 1. Minus 3 then to the power of 2. Minus 3 to the power of 3. And the final term is going to be minus 3 to the power of 4. I'm just going to put pluses between all those, and then I'll change the signs later when needs be. Okay. Now you could have used 4 choose 0, 4 choose 1, 4 choose 2 with this if you want, because you have the calculator, you can do that either. Okay, so 2x to the power of 4, that is 16x to the 4. And this is going to be, all right, now, maybe I need the calculator for this one, but 2 cubed is 8. 8 times 3 is 24, and 24 times 4 is 96. And I know it's a negative because it's, that's negative 3 to the power of 1 just. So it's negative 96x cubed. X cubed. I know the next one's going to be x squared anyway, so, and I know it's going to be positive because that minus 3 is squared. Once again, 2 squared is 4. 4 times 6 is 24. 24 times 9 is 216. Use your calculator. X squared. Next one then. Minus 3 to the power of 3 is going to be minus 27. I'm just putting in the minus. Minus 27 then times 4 times 2 is also 216. There's only 1x. This one had no x term, and it's just 3 to the power 4 minus 3 to the power 4, and that's plus 81. That's it. Okay. And the last question. In this expansion, the coefficient of the x6 term, okay, so we're looking for the x6 term. Now, this one I'm going to use the general term. This is my binomial, this part here, 5 plus px to the 8. That's the binomial bit, because it's got the 2 terms and it's 2 power. I'm looking for the 6th term. But I do also notice that this thing, the px squared in front, is going to multiply every term in this expansion by x squared. Every term. Which means if I found the x6 one from this, it's going to end up being x8, because it's going to be multiplied by this. So I'm actually looking for the x4 term from this, haven't I? Hopefully you noticed that in the exam. This is probably the hardest question in the exam. So I'm looking for the x4. X to the power 4. Because that's going to be multiplied by x squared and make x6, which is the one I want. All right, so let's look at the general term. I know 8 is here anyway. I'll come back to the rest of it. I know 5 is the first one, and I know px is the second one. And I know that afterwards, it's going to be multiplied by px squared. All right, okay. Now looking at my powers, how am I going to make x4? I think it's pretty straightforward. I think it's just that needs to be 4, which means that needs to be 4, because 4 plus 4 need to give 8. And if that's 4, this is 4. Done. All right. 8, choose 4 from the calculator. Let's remind ourselves how to do that. So you type in 8, then you go to math, probability. So I scrolled over to number 3, NCR. 4, press enter, and we get 70. So that is 70. Okay. Now px squared is still here. I haven't put in this number yet, but it all does equal that. I get 3402 x to the 6 if you want to put in the x to the 6. 75 to the power 4. Get your calculator out again. I'm doing it to the side here. That's 625. And that's going to give me P4, X4. And this is okay. Now I know that this X6 is really, I'm not caring about the X6 term. I kind of just figured that out, that it is the X6 term, but that would make X6 and then divide both sides by X6 and then it's gone. I'm only looking at the coefficients, the number. And it's important here that I didn't forget that P by this one is P to the power 5. So I get 3402 is equal to 70 times this, which I have done already, 43750. So you just do that on your calculator. P to the power 5. And so it's going to be 3402 divided by 43,750 is equal to P to the 5. So I get the 5th root on my calculator, and it will be P. So I think if I go press 5 and then go into math and put in that, then do my brackets. 3402 divided by 43750. 0.6. 0.6. That's it. P is 0.6. Calculator did it for me. 5th root of that. And that is the final answer. So if you were to set up something like this, but not quite finish it, you'd probably get 2 marks out of the 6. If you got maybe this far and didn't finish it,
Sir, I think you muted yourself.
Thank you, Matthew. Yeah, Mr. Gibson just called in. Okay, so I can't remember where I finished. Oh yeah, so let's talk about marks for this one. If you got that much, kind of set it up but weren't sure what to do next, you probably get 2 marks. If you put in the 4s. If you just did this and didn't put anything in, you probably get 1 mark. If you got this far and then weren't sure how to finish it, you probably get 4 marks. And if you got the final answer, you get 6 marks. Yeah, and that's it. So any questions then on any of that? Deathly silence. Okay. Now, Laura, I know you did a question on the last one of the practice questions, but I don't think many people have attempted that, so I don't want to give fully away the method on that yet. I want people to have a look at it and try it. So over the weekend, I reckon a good idea to get